Hello, everyone. Today, I'm going to show you an incredible journey of transformation, taking what seems like ordinary, discarded household items and turning them into incredibly versatile and powerful tools. You might think these simple objects are only good for their original purpose or even the trash, but I'll reveal how we can unlock their hidden potential and give them a completely new lease on life. Get ready to have your mind blown by these surprising DIY projects. Then I stripped off the outer insulation to expose the copper wire core inside. To get a clean and secure connection, I'm twisting the individual copper strands of both wires tightly. Next up, I'm taking a spark plug. I'll use pliers to carefully remove the top metal cap. This part isn't needed for our design. I've got a standard AA battery. I'm going to use my pliers to carefully dismantle it. After completely removing the shell, I will use a box cutter to cleanly remove the plastic layer on the battery. The goal here is to extract the carbon rod from the center. Then, I use pliers to carefully remove the metal positive terminal cap from the top of the battery, then pliers to gently pull out the carbon rod. With the carbon rod extracted, I'm cleaning it thoroughly with a paper towel. For a crucial step, shaping the carbon rod, I'm inserting it into my drill and using sandpaper to give it a fine, pointed tip. This sharp point is key because it will allow for very precise heat concentration, making our tool effective. Once it's perfectly shaped, I'm inserting the carbon rod back into the spark plug. I've got a PVC pipe here, and I'm using a hacksaw to cut it to serve as the main body of our tool. The PVC will provide excellent insulation and a comfortable grip, making the tool easy and safe to use. After cutting, I'll clean the edges of the PVC pipe to ensure there are no rough spots. I'm inserting the spark plug element with the attached carbon rod into one end of the PVC pipe. It needs to fit snugly for stability. I'm positioning a small switch on the PVC pipe and marking its outline with a pen. This section will house our switch. Accurately marking it ensures the switch sits flush and operates smoothly. Using a hacksaw, I'm carefully cutting out the rectangular opening on the PVC pipe based on my markings. Then, using an angle grinder, I'm carefully cutting out the marked section on the PVC pipe. This slot is essential for integrating the switch into the handle, allowing us to control the heating element conveniently. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. With the opening prepared, I'm inserting the switch into place. It should fit snugly. I will take a red insulated wire and strip one end to expose the copper wires. I will twist them to make a secure connection. I'm connecting one end of the red wire to the carbon rod so that the contact point is open on the spark plug. A good electrical connection is vital here. To ensure safety and prevent any short circuits, I'm using red electrical tape to insulate the connection points around the spark plug. This is a critical step to make our DIY tool safe to handle. I'm carefully feeding the wired spark plug into the PVC pipe. I'll make sure the red wire is positioned correctly inside. I'm carefully dismantling the small white switch, exposing its terminals. I cut the red wire at the switch location in half to prepare the wire for connection. I stripped the insulation from both ends of the cut wire and twisted them neatly. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I will connect one of the prepared red wires to one terminal and the other red wire to the other terminal of the switch. I'm tightening the screws firmly to ensure a secure contact. This controls the power flow to our heating tool. I repeat connecting the remaining wires to the switch the same way as before and make sure the connections are secure. With the internal wiring mostly done, I'm carefully pressing it into its designated opening on the PVC pipe. To ensure everything stays put and is well insulated, I'm using a hot glue gun to seal the edges around the switch and secure any loose wires inside the PVC pipe. Safety and durability are key for any DIY tool. Now for our external connections. I took a blue wire and attached an alligator clip to one end. I'm integrating the laptop charger. I'm going to connect one of the stripped charging wires to the blue alligator clip we just made. This will be one half of our power supply. I added a heat shrink to insulate the wire connection afterwards. After the wire is securely connected, I use a lighter to heat the wire connection to protect it. Now our power adapter has both positive and negative clips, ready to power our custom tool. I'm plugging the adapter into an extension cord. See how instantly it heats up? This little tool is surprisingly powerful. I use this small piece of wood to make a work table to prepare for welding. I will prepare some razor blades and place them on the wood. Watch closely as I press the switch. Incredible, right? You can see the tip instantly heating up, ready to melt solder or plastics. When I turn off the switch, my welder immediately stops working. Look at that. Clean, strong solder joints, just like professional welding. This truly shows what you can achieve with a bit of ingenuity. Now I'll show you 2 more repair tips for recycling old items into soldering irons. Watch how I do it. Now that it's cleaner, I'm carefully unscrewing all the screws on the drill's casing. This allows me to access the internal mechanics and prepare it for our modification. With the screws out, I can now gently open up the drill. I'm brushing away any internal dust and debris to ensure all the components are clear and ready for the next steps. Now, I'm carefully removing the chuck and the gear assembly. I'm taking a piece of PVC pipe and marking it. This measurement is crucial because this pipe will form the core of our new internal component. Using a pipe cutter, I'm making a clean, precise cut on the PVC pipe at the mark I just made. A straight cut is essential for a snug and secure fit when we place it back into the drill. Now I'm drilling a hole through the center of the PVC pipe. I'm drilling another identical hole on the opposite side of the PVC pipe. This pair of holes will allow the ends of our coil wire to pass through neatly, ensuring proper connectivity. I'm using a utility knife to smooth out the edges of the newly drilled holes. For the core of our heating element, I'm carefully wrapping a thin resistance wire around the PVC pipe, threading it through the small holes. This wire is crucial because it's designed to heat up significantly when electrical current passes through it. I'm sure the coils are evenly spaced, which will help create uniform heat distribution. Once I completed the winding, I'm trimming the excess wire, leaving enough length on both ends for our electrical connections. To ensure safety and proper insulation, I'm wrapping the entire copper coil with black electrical tape. This prevents accidental short circuits and protects the delicate windings from external damage. Next, I'm adding another layer of insulated yellow wire, wrapping it around the electrical tape. This secondary coil will act as an inductor, enhancing the overall magnetic field and concentrating the heat from our resistance wire. I'm stripping a small section of insulation from the ends of the yellow wire. Exposing the copper is necessary to make proper electrical connections later on. I'm securing one end of the yellow wire by tying them neatly around the main copper wire leads. This ensures the windings stay in place and prevents them from unraveling during use. I'm repeating the stripping process for the other end of the yellow wire. I'm carefully attaching the newly created coil assembly to the motor's rotor, ensuring a solid electrical contact. This is the heart of our modification, bringing the new function to life. With the modified motor assembly complete, I'm placing it back inside the drill casing. I'm also reattaching the chuck, ensuring everything fits perfectly and is aligned correctly. I'm taking one of the yellow wires and connecting it to the drill's internal wiring. I use a screwdriver to remove the power cord from the drill. Then I use pliers to cut and strip the power cord from the drill switch. I'm now carefully reconnecting the internal power wires and using electrical tape to insulate all exposed connections. This step is incredibly important for safety, preventing any short circuits or hazards. With all the internal components in place and securely wired, I'm closing the drill casing and screwing it back together. I make sure to tighten every screw, ensuring the drill is robust and ready for use. This step ensures that the tool is robust, safely enclosed, and ready for action. Our modified drill, looking good and ready to prove its new capabilities. Who would have thought this old drill could become something so different? To power up our creation, I'm plugging the drill's original power cord into an extension strip. See that? It instantly lights up. Our transform drill can now power other devices. As you can see, the extension strip is working, ready to deliver power to our device. I'm inserting a metal welding rod into the drill's chuck. This rod will become the electrode for our improvised welding setup. The strong grip of the chuck ensures secure connection. I'm using the drill to weld these two pieces of metal together. Watch closely as the concentrated energy from our modified drill melts the metal, creating a strong bond. This homemade welding tool is surprisingly effective. You can see the intense heat and sparks generated, capable of welding light metals. This drill is actually welding. After welding, I'm using a hammer and a wire brush to clean off the slag from the weld. This reveals a clean, strong joint we've created with our transformed drill. Our incredible multifunctional tool transformed from a simple, old drill into a capable welding device. Next, I will recycle compressor part, which is considered scrap after it's been decommissioned, into a welding machine. I'm going to begin by applying some WD-40 around the compressor's seam and cleaning it thoroughly. This helps loosen any rust or grime, making the next steps much easier and ensuring a clean working surface before I get into the real work. I'll remove the small electrical box located on the side. With the box off, I'm now ready to open up the main shell. Using an angle grinder, I'll meticulously cut along the seam that runs around the compressor's body. This creates a clean opening, allowing me access to the internal motor. This step generates a lot of sparks, so always make sure to wear appropriate safety gear. After the initial cut, I'll use a screwdriver to carefully pry open the casing, revealing the internal components. With the casing open, you can see the compressor motor inside. Now, with the motor removed, I'll start by cutting the wires that connect the internal components. This allows me to separate the main motor unit from the rest of the housing. With the motor assembly isolated, I proceed to disassemble its housing, removing the fastening bolts and separating the outer shell. The primary objective here is to access and extract the laminated steel core and its copper windings, which will serve as a foundation for our induction transformer. Each component is carefully handled to prevent deformation or damage. This meticulous approach ensures the integrity of the core material for optimal performance. The laminated steel core and copper windings are now isolated. Now that I have the motor assembly, I need to strip away some of the outer insulation from the copper coil wires. I'm using a utility knife to carefully score and peel back the plastic, exposing the bare copper. This is crucial for making good electrical connections later. Next, I'm preparing the wiring for our primary circuit. I'm stripping the ends of some red and yellow electrical wires, then twisting them securely onto the existing coil connections. This creates a strong electrical and mechanical bond. After twisting, I'm insulating each connection carefully with red electrical tape. This is super important for safety, preventing any short circuits once power is applied. I'll repeat this process on the other side of the coil, attaching lengths of yellow electrical wire, stripping, twisting, and then securely taping them with red electrical tape. The insulation is key here for both functionality and safety. Next, I prepare an orange male electrical plug. This involves carefully disassembling the plug housing to access its internal terminals. The stripped ends of the red and yellow wires from our modified transformer are then securely attached to respective prongs of the plug. Each connection is tightened using a screwdriver to ensure optimal electrical contact and prevent loose connections, which could lead to arcing or overheating. The plug housing is then reassembled, securely encasing the wire connections, thereby completing the primary side's electrical interface. For the secondary coil of our welder, I select a segment of PVC pipe. I'll measure and cut a suitable length of pipe. I'll clean any burrs from the PVC pipe with a knife. Then, I'll drill 2 small holes to the side of the PVC pipe. This hole will be used later to secure our components. Subsequently, I begin winding a length of red electrical wire around the PVC pipe. The wire is systematically threaded to the pre-drilled hole and tightly wound around the pipe's exterior. This process creates a solenoid, which will function as a secondary coil for our induction welding apparatus. The turns are kept uniform to maximize electromagnetic coupling and efficiency, ensuring the desired output current for welding applications. Once fully wrapped, I'll cut the wire and make sure it's secure. Now, let's bring our two coils together. I'm inserting the PVC secondary coil into the center of the primary coil, ensuring a snug fit. This close proximity is essential for electromagnetic induction. To keep it all securely in place, I'm using 2 zip ties to firmly fasten the PVC pipe within the transformer. Once secured, I'll trim the excess from the zip ties. Next, I'm connecting the wires from our secondary coil to a pair of heavy-duty alligator clips. These clips will provide the electrical contacts for welding. I'll strip the ends of the wires, insert them into the clips, and crimp them securely. Now, to prepare the welding end, I'm taking the specialized welding electrode holder. I stripped the outer insulation of the remaining red wire and secured it securely with this special soldering iron. The stripped wire ends are then firmly attached to the copper jaws using screws, ensuring robust electrical contact. The welding clamp is then reassembled, securing all internal connections and the handle. This comprehensive preparation ensures reliable and safe current transfer to the welding electrodes. After securing everything, I'll test my main power source. Perfect! The light comes on. I'm plugging the transformer's modified plug into the live extension cord. I took the soldering iron and attached it to the soldering clamp. Then I attached the alligator clip to the iron bar that needed to be soldered to complete the circuit. See that bright flash in the molten metal? This successful demonstration underscores the viability of repurposing industrial components for specialized applications. If you find the video interesting, please give me a like. Don't forget to share it with your family and friends. Thank you for your support. Bye. See you in the next video.